Hi, everyone, and welcome to our webinar, Discovering Personal Data in Financial Industry. As you can see, the webinar is recorded and the video will be available on our YouTube channel later on. My name is Petra Jerkovic, and I am Client Relationship Manager at Data Privacy Manager. And before we start, let me give you a quick overview of our Data Privacy Manager solution. Data Privacy Manager is a comprehensive privacy solution for personal data management, and it is an innovative software as a service platform developed and hosted in European Union. It is designed to solve specific privacy challenges that include consent management, automation, data subject request, data processing inventory, third-party management, and more. One of our modules is our data discovery, which we will be talking about today, and that is an AI-based solution designed to automate personal data discovery and classification using state-of-the-art machine learning approaches to discover, classify, and manage all personal data, both structured and unstructured, across all the systems within your organization. As you can see from the invitation, today's agenda consists of presentation and demo, followed by short Q&A session where we will answer all of your questions. So feel free to write the questions in the chat in real time. And at the end, we will have time to answer all of your questions. And the questions we maybe not manage to answer on today's webinar, we will send you in our follow-up. And now I'm happy to introduce you to our head of research, Ana-Marija Petric. Ana-Marija has over 10 years of experience in AI and data masters in linguistics at the University of Oxford. She specialized in the field of natural language processing and the application of AI in privacy protection. And she's in charge of building proprietary technologies and approaches to data protection and compliance automation. Today, Ana-Marija will demonstrate to you how to discover both structured and unstructured data, as said, in two real-world use cases from the banking sector. Ana-Marija, so whenever you are ready, the floor is yours.
Thank you, Petra. Hi, welcome everyone. Thank you for the introduction, Petra. So as Petra has mentioned already, we will be talking about how to discover personal data specifically in financial industry, but also if you are not strictly in financial industry, a lot of the topics that we cover today may apply to you as well. So without further ado, let me just start, and we will briefly discuss the key topics that we will cover today. So I've divided these key topics that we are going to discuss into 4 broad areas. The first one is the challenges in financial systems. When we talk about financial systems, we are well aware that they are complex. They have a lot of sensitive data. They contain a lot of different services. They contain a lot of different products. And for a lot of these products, they usually collect a lot of personal and sensitive data. One of the things that affects financial data in particular is the complex regulatory landscape. When we talk about complex regulatory landscape, and I'll go into more detail in the next slide, we are referring to not just the data protection, privacy protection, but also the data governance acts, etc. The next topic will be the DPM Data Discovery. I will briefly mention how we handle different types of data. So unstructured data, which can be in the form of bullet point documents, it can be contracts, it can be very legal, it can be also emails, which are in general a lot less formal. And then we will talk about how do we create context and extract personal data in tabular data. So when we talk about relational databases and systems, this is how we will create these contexts for machine learning to be able to identify personal data inside. The next topic that we will cover is the data inventory, which is the centralized repository of all the personal data divided by different systems. One of the very key points that I have to mention ahead of time before we delve into the topic is that data inventory collects only metadata. This is something that we as DPM provide for you, but we don't collect your personal data. We only give you the information about its location and enable you to assign different risks to systems based on different personal data that is contained within a system. The next functionality that we also enable inside of the data inventory is tracking the scans through time. So you can see how the data has changed if you have had many or major interventions in your systems, etc. And lastly, I would like to just briefly go into the privacy landscape in finance, talk a little bit about how the modern machine learning relates to privacy regulations and how we enable different companies in Europe and abroad to use data discovery, and how we enable, through the use of data discovery as the initial step, the journey of becoming a privacy-driven enterprise. So, the first topic that I want to cover is the areas of complexity. Now, this is perhaps the most difficult slide to kind of sum up because it's really a lot of topics that we need to cover. However, financial industry first and foremost needs to balance between data collection and protection while also delivering a highly personalized experience. And it faces, as I already mentioned, a really complex regulatory landscape with GDPR and others. When we talk about financial industry specifically, to provide, for example, accurate credit ratings of people and businesses, financial industry does depend on sharing of data. Anything from creating a simple savings account to acquiring loans to buy your house or a car, or whatever, to getting an ATM card issued and transferring funds. Personal information is required for all of these, all of these services. And the problem arises when you have multiple different services for which you collect different personal data. There are obviously different expiry dates of this data, right? So somebody may not want to have a credit card with you anymore, or somebody's loan might be completed and they might want to switch banks, etc. So this creates a lot of complexity as well. When we talk about privacy regulations, since the introduction of GDPR, which was in 2018, just to remind us all, there has been over 60 jurisdictions around the world which have either created or proposed a privacy or data protection law, including but not limited to Brazil, Japan, Thailand, China, California in the US, etc. One of the consequences of having these multiple different regulations, a sort of a fragmented privacy landscape, right? And this creates a lot of uncertainty for financial institutions in particular. For example, in the US, there are multiple calls for the federal data protection legislation as more and more states are increasing their data protection laws. For example, the Virginia Consumer Protection Act, which is set to go into effect in 2023. Now, different privacy regulations obviously have different consequences because they create a lot of different compliance requirements, especially if you operate globally. The next topic that I want to cover is the security. Now, in the most recent IBM Security Cost of Data Breach report, financial industry is the second highest cost at $5.97 million in 2022, which is the increase of 4.4%. Also, Security Boulevard reported that about 74% of the applications that financial services use have security flaws. However, as dismal as this number is, it's usually one of the higher ones in the industry in general. Now, lastly, it's very important to understand that digital security incidents affect the integrity, availability, and confidentiality of data stored by financial service providers. And these kinds of incidents have become more common and on the rise globally. Now, the prerequisite of ensuring personal data security is the ability to know that what kind of data you have and where you actually have it. And this is something that data discovery is designed to aid with. Lastly, one of the challenges is also data storage and use. Financial institutions often have to share data between entities or even across borders. This is particularly difficult for those companies that operate both in the EU and the US due to the lack of transatlantic legislation regulating the transfer of data between EU and the US. And then we also have creation of data flows for credit scoring, where you also have to be very mindful of personal data. And you have obviously different legal limitations on use. For example, it's very different how you use transactional data versus data from, for example, social media. And obviously, lastly, it's reputational damage, which can occur due to not having proper privacy policies in place. And this has happened to Meta, Apple, and Google, which have all been affected by the certain reputational losses due to the personal data protection laws, both in the EU and the US, specifically in California. So this kind of paints us a picture of what we are dealing with when we are talking about financial industry specifically. We have to really balance both the legislation on one side and the complexity and the amount of data that financial institutions collect. And furthermore, we also have to be mindful that inherently financial data is seen as really valuable and therefore at a larger threat of being compromised or stolen through unlawful activities. All right, so this kind of introduces to us what we are dealing with. Now, before I delve into what data discovery does, I want to just very, very briefly discuss my areas of expertise, which is linguistics and language. And I won't bore you too much with the technical details, but let us just kind of understand why it's very difficult for language to be interpreted by a machine. Now, most of us know that machines cannot read words, and we deal with a lot of different issues when we talk. Like now you're listening to me talking, and I'm using very complex sentences. Maybe I'm making some small mistakes, etc. And this all has to reflect in the models that we train to classify data. There are three particular concerns when we are talking about language in the context of discovering personal data. One is that language is very complex. People communicate and write differently depending on the type of communication. So a lot of us will not write the same tone of an email to our boss and to our best friend. We will not have the contracts written in the same way as personal correspondence. And we will not use the same language, the same vocabulary, the same structures, etc. Language is also very inconsistent. Not all of the people have the same level of literacy and attention to detail. Writing conventions also influence the communication. So sometimes when you write in Croatian specifically, if you're writing from your mobile phone, you will not use diacritics. You will use just simple C's everywhere instead of paying attention to how to properly spell. And this also presents a problem for a machine, because machine is usually taught on proper language, right? And lastly, textual data can be tabular. This is something that is very difficult for models that are trained on language to understand, because tables, although they are much smaller, they don't have a lot of context. There are not a lot of clues, so to speak, to decide what's actually inside of the table itself. So these are the three challenges that you have outside of financial industry, in any kind of machine learning for privacy protection. And lastly, we also have the issue of different contexts, right? So a couple of months back, I was giving a lecture at Thomas More University, and we gave these two sentences to our classifier. Thomas More is a famous philosopher. Now, obviously, we as humans know that Thomas More here is a person, right? It's a philosopher. Philosophers are usually persons. And if you say Thomas More is a famous university, you have only changed one word, but this Thomas More is no longer a person. And your model, when you put it to work, it needs to disambiguate these things. And it's particularly relevant for companies that are usually formed in such a way that the surname of a person is used, and then you have to be able to know that this is actually an organization and not a personal name. So this is something that you also have to be very mindful of when you are using machine learning. When you're training it and when you're teaching it how to recognize these different contexts, to kind of be able to classify correctly whether something is a person and therefore a very important category, or something is an organization which might not be subject to strict controls inside of your systems. All right, so when we talk about context, right? So one of the important things that we need to understand is that not all of the data that you have on your unstructured data sources is the same. Some of it is very easy to interpret, and some of it is very, very difficult. So in particular, contracts, resumes, invoices, etc., they have very complex context landscape. And what does this mean? This means that if you look at your right-hand side, you can see this employment contract. And you can see here that you have some parts of the text which are bolded, some parts of the text which are bulleted, etc. You also have this little header on the top of the document. And all of this increases the complexity for the model, because the model has to also understand the sentence, whether it's very short and it's a bullet point, or whether it's a very long paragraph, as in the first case of this particular contract. So, and also you need to be aware of how many different formats of data you can have. And it needs to be able to ingest all of them. So you can have PDFs, you can have Microsoft Word documents, you can have Excel formats, you can have simple TXTs, etc. And you obviously need to be able to ingest all of this data, classify it correctly, and then output the correct results. So all of these issues arise when you are trying to train a privacy-sensitive machine learning model. In particular, the second issue is the tables. Now, if you look at a table, how the language models work, they kind of take all of the data that surrounds a particular word. So, for example, Ana-Marija is giving this webinar. It takes all of this information that surrounds Ana-Marija to conclude that this is a person. In tables, we don't have this kind of context. So in the first table, you can see, okay, we can create some kind of a context because we have name. Names are usually associated with persons, organizations, or pets, animals. We have a phone number, which usually contains phone numbers, and we have an address. So that's fine. We can conclude that data that is found in these particular columns is of this particular type. However, in the table 2, also, we can have customer, business phone, and contact. All three of these words point to the data that is contained inside of the table. So theoretically, you could say, okay, everything that is a name is a person, everything that is a phone number is a phone number, and everything that is a business phone is also a phone number, and everything that is a contact and an address is an address. So you could kind of create a very simple regular expression and say, like, okay, whenever I see this column, I'm going to assume that this is address, even though contact in and out of itself may not necessarily always contain address. However, you can have a situation like this, where you have a table where the first column containing personal names is called alpha_1. And you have tel number written as tel NR and address as ADDR. So does that mean that you now have to say, okay, wherever you see alpha, this is a person, right? Whenever you see tel NR, this is a phone number. Whenever you see ADDR, that's an address, right? So you can kind of expand this list of things that is considered a particular category. But you can already kind of guess that this would become very complex very soon, because we're not talking about 4 tables or 400 tables or 4,000 tables. We're talking upwards of 40,000 tables or 400 tables, even for some large systems. And obviously, you can have sometimes something that is completely not informative, where you can have address written in a column called note, and in one system, in the column called note, you will have an address, and in another system, you might have contacted on the 31st of January. So it's not really informative. It doesn't tell you, okay, in this particular column, I always have an address. So what this means is that when you're dealing with these kinds of complex tabular systems where you use the same words to refer to different things or use different words to refer to the same things, you might have a problem creating a non-intelligent, quote unquote, system. That's why we have opted in our design not to rely on the column name, because we cannot always rely on it. If it's there and if it's informative, we will take it into account, of course. Okay, and obviously one other thing, and this is particularly relevant in the region where we have two different scripts, so Cyrillic and Latin. You can have tables which contain both, and you can have also English column names, especially if you are using SQL relational database. Some of the tables will be completely in English, some will be in the local language, and some in the countries that use dual script, so that use both Cyrillic and Latin, you can have both. And this presents a problem for a lot of the out-of-the-box solutions, which explicitly state, such as, for example, Azure explicitly states that all of the data surrounding a personal data entity, so for example, name, etc., has to be necessarily in English. So for our system, this is not relevant. We can classify customer in the same way as telefonski broj or adresa, even though they are written in a Cyrillic script. So this kind of gives you an overview of what we are dealing with. And now I'm going to show you how we actually handle this in data discovery. So first, when we talk about unstructured data, we have color-coded relevant personal data. So if you look at the employment contract, which I already showed you, without these labels, you can see that we have the state of Illinois, which is in blue. Then we have personal assistance, which is an occupation. We have some dates, we have some addresses, we have some names. We can see here that this is a contract between somebody called Judith Davis, who's an employee, and somebody called Javier Sullivan, who is the employer. So you can have these kinds of contracts where you can actually find all of these different data. And on the right-hand side, you can see also that we have different languages. So this one is classified, it's also a contract, or it's a rule book, actually, where we also have different data labeled. And we can see, obviously, that this text is in Croatian as opposed to English. And this kind of just shows you how we can actually classify personal data in different languages. When it comes to structured data, and I picked a particular example which did not have column names that are informative, how we do the classification here is we actually take a sample from the table, which is obviously the data discovery. I have to mention this is installed on-prem, so it's in your infrastructure. It doesn't leave. We don't send anything outside of your infrastructure, so it's very protected, and we don't use the entirety of your column to base the decision on. What we use is a subset of data which is representative of this particular data, and it shows under the particular column. This is A002. We can see this is a person. The sample size is 12, and you can see here that you have some surnames, and we obviously label that as person. Other ones I will show you in the demo also have a similar sample. So you can, before you accept, so to speak, the results of data discovery, you can always see the sample. And obviously the human input is the most important. The experts that work in your companies are the ones who know your data the best, and they can always validate and check the data that is contained and say, okay, I can see that the sample corresponds to the label, and you can then accept these results. Now, one note, this is synthetic data. This has been generated, so it's all personal data, and that also explains why the percentages are 100%. But usually, when the data is clean, when the data is nice, our model is somewhere at the ballpark of 98, 99%, depending on the category of the data. So every time, as I said, you can see both the sample and the confidence percentage, how sure the model is, which parts of the model classified it, whether there is personal data or not. So you can see here the other data labels. These are the columns that don't have personal data in them. So you can see that visually you can filter based on these particular binary classifications, whether something is or is not personal data, and you can review for all of them what the model has based the decision upon. So this is kind of like how we make the data discovery, and I'll go into more detail when I show you the demo, but just to give you kind of like a preview of how this is done. Once we have classified all of the data in your databases, and we have found personal data, you can publish this metadata, the information about this particular scan, about this particular system, to our module called data inventory. Data inventory is a central sort of repository for you to see specific dashboards. So you can see where your data is located. This is particularly relevant if you have multiple different locations in which you process data. You can see where certain systems are located, how many systems are in certain location, how many personal data categories have been found, how many objects have been scanned, etc. You can see the information which is available about the classification process itself. You can see the timeline, so you can see how frequently and on what particular day you have scanned it, and you can obviously load the results of previous scans. You can only see the object name, so this is the column and the table name. Object name is and column name, and you can see that which part of the engine has classified it. So for this particular first column, customer name, we see that our engine has classified it as person. And below, you can see that you have also a .x document, a Word document, where you also don't have the value of what actual name is, but you know that in this particular document you have an entity which is a person. So you might want to handle this document in a different way once you know. Maybe you want to delete it, maybe you want to anonymize it, maybe you don't want to keep it because you need to protect it, then you can kind of act upon this particular information depending on whether you have or don't have personal information in it. You can obviously filter based on different categories, on different types of data. You can review the classification, and you can see here from this very small screenshot that you obviously have also some informative column names and some less informative column names, like you have customer name, last name, etc. And it works exactly the same for both your documents and your tables. You will not see the actual sample in this particular module, but this module always goes hand in hand with data discovery, because data inventory allows you to assign specific risks to specific systems, to evaluate, to track changes, to very quickly filter specific categories of personal data, etc. So this is something that goes together with data discovery really, really well. All right, so one last semi-technical slide, if you will. I just want to briefly talk about machine learning, specifically natural language processing part of it. I'm pretty sure that most of the people by now have heard about ChatGPT. Some of you have probably used it as well, and this is obviously a large language model, right? It's a machine learning large language model, LLM, and these models are great. They work in all kinds of languages. They are really, really good at what they do. They're not as good as humans, but they can do a lot of legwork for you. If you have tried it, you have perhaps, if you were inclined like me, you have tried to get it to kind of give you some personal information about real people. It doesn't want to do that. You can verify it. It will say like, I don't want to generate any personal information about a specific person. So you have to really indicate if you want to create some personal information that it's a public person or it's somebody who is completely fictional. One of the things that you need to understand with language models, especially large language models, which are really, really good, to be so good, they require a lot of infrastructure, a lot of hardware, right? When we deploy our models in a particular company, this is not always the case. Not a lot of companies have dedicated GPUs to run very large models. So what we needed to do in order to make this technology accessible is to enable it to work in all languages, but also to work on relatively affordable hardware. What this means for technically minded of you, this means that you can actually run it on a CPU. You don't need to buy a dedicated GPU to run our models. And this is something that applies to both structured and unstructured data discovery. Although if you have a GPU, we'll be happy to use it. So, sorry. So privacy regulations, as I already mentioned, they apply, for example, in Europe to all European countries, but it's not equally easy to do personal data classification in English and Croatian, for example, or English and Slovenian or Macedonian or whatever. And these smaller languages usually don't have such quote unquote good models. They're not trained as much, and they are not as popular as bigger languages. And what this means is that it's very difficult to use machine learning models in these smaller languages. Now, if the legislation requires all companies to use and abide by the same laws, if you want to use the same technology, usually you have to invest a lot more resources to kind of enable it to work in Croatian, or even it will not work at all. So this becomes very, very difficult. And for us, it was very important from the get-go, being in the region, right, and valuing the customers in the region. We wanted to build a model that is multilingual from the get-go, that could classify, as I showed you briefly, both in English and Croatian, and also obviously other languages such as Greek, Macedonian, Serbian, etc. But also in the major languages such as Chinese or French. And one of the other things that obviously we had to ensure is that it works on all kinds of scripts. So we don't have to require that it is in Latin script in order to be able to classify. And we had to do all of this without relying, as oftentimes some of the companies will, if they need to quickly translate something, they will send it to Google, right? But since we are doing personal data, we cannot send anything outside of the company, right? So we really needed to build all of the components inside of the data discovery to make it more secure, to make it more privacy sensitive and privacy driven. So this is something that differentiates the software from other ones, is that we from the get-go really wanted to dedicate time to build this particular feature into our software. And the last thing before we go to the demo is that summary of what I've just said and explained is basically that in order to be good for privacy, data discovery has to be able to identify personal data in both tabular and non-tabular sources. This means it should behave well, even on relational databases, but also on the documents that you have perhaps in your Google Drive, OneDrive, etc. It also has to have multi-label capacity. And this is something that I haven't mentioned still, but I will take the opportunity to go into right now. And that's the ability of our software to identify that certain column has more than one type of personal data. This is, for example, if you have a column called contacts, which can have both phone number and email address depending on the customer. So some customers prefer to be contacted by email, some perhaps prefer to be contacted by phone. What our software enables is the ability to identify both of these labels. The third capability that it has to have is to be able to function in one and multiple languages. And this does not apply just on, okay, in one company you have one language, but as we have seen in a lot of the smaller languages communities, you will have at least English and a local language. So you will have at least 2 languages. And if you're doing business internationally in your operational business, you might have correspondence with multiple different representatives from multiple different countries, which may or may not use their own local languages. So it has to be able to function in a multi-language environment, even if we are just having one company inside of one specific country with one official language. And the fourth thing, it has to allow for a high degree of flexibility. It cannot be rigid. As I mentioned, it cannot rely just specifically on the column names. It also has to take into account the knowledge of the people that use it, right? So what we built in the data discovery is the ability to write your own regular expressions based on your business rules. So if you know for sure that in some particular system, you want to identify a completely company internal category, which has a specific format, you can define it and you can say, okay, for each future scan, I want to have this particular category. For example, maybe that's a policy number, which you have defined, which is not part of the personal data as a whole, right? We will not go and have everybody have the category of your policy number because they might not be the same across 2 different institutions, but you may create them yourself and you can store them and they become part of your data discovery. So this is something that is by design, part of data discovery, to allow the user to control what kind of additional personal data we find. And lastly, there is also the ability to manually override. This is something that we consider very important. The onus and the final say of every machine learning model is the human. The evaluation and the value of the employee who evaluates and knows this data has to be reflected somehow. And for this particular reason, we have also enabled the users to override specific categories with their own internal categories, which they may define or load from our predefined list of entities. So this is something that we give the control back to the user to kind of be in an interaction with the software itself. So last thing that I want to kind of say is that when you have all these functionalities, what data discovery is designed to do and what it actually does really, really well is really be a stepping stone in becoming a privacy-driven enterprise. Because in order to tackle the processes of retention of data or removal of data, the prerequisite is knowledge of where the data resides, what kind of data is where, etc. And this is something that data discovery really is designed to do. It points you to the locations of particular data types, it aggregates them for you, and then you can review them and build upon these particular results. Okay, so I'm just gonna stop sharing this quickly and we can go into the data discovery itself. So this is the client, the application, and I opened the document that we have discussed, which is the employment contract. And what you can do here is really like scroll, right? So you can go to different parts of the text by clicking on these particular domains. And you can see if I click on first person, it tackles the Judith Davis. I can see that this is the first person. If I go all the way down, it takes me to the particular location where I have where I can see Mr. Sullivan. So it allows you to go through the document by using these particular boxes on top. So if you wanted to go back to the address, it automatically goes back. One of the things that is very important when you're thinking about these kinds of documents, right? which are written, like contracts, etc., we render them the way they are. So if you have specific spacing, if you have specific fonts, they are rendered in this particular way as well. And this is so that you can, if you have a need, know exactly where a particular data point is. If you see Judith Davis and you want to, for example, remove or anonymize her, you know the actual location where this particular person is mentioned. Here you have the document info, so you can see where it is. You have a link that takes you to a particular OneDrive, so you can perhaps remove it, or you can do something with it very easily. And here you have the history, when it was scanned, how frequent, and what kind of data you have found in this particular document. And obviously, you can see here on that we have all kinds of different documents. So, for example, we have this one, which is in French, and it also has a picture, which has also been rendered. And this is what I mean when I say like documents are actually rendered as they are. So if it has a picture, the pictures will be shown, and you can see that you can do the exact same. So you can go through the document and verify that all of the data is correct. So this is when something that is very, very, very useful for unstructured data, because you can really go through the entirety of the document, and you can verify that all of the data is found. You can see here the dates are obviously also recognized if they are written out and not just in a date format. So this is kind of how the data discovery on unstructured data works. You can group these kinds of domains. So you can just review the personal data, click on all of the persons, right? And you can do the same for all kinds of different categories. You can group by all kinds of different things. You can view it, etc. Then you can have different kinds of formats. So, for example, you can have CSV files, which are like this, and you get the labels on top, right? So if you have CSV files or an Excel files, they will give you the labels on top of it, and that's how this will also work. And if you have documents which have no personal data, then you can see that they don't have any personal data based on the icon that they have. So you can see in this particular document, we have no personal data at all. Going back to the structured data, you can have, for example, different kinds of columns. Here you can see that we have account type, which is current or deposit, and this is your sample. Then you have the contacts email, right? So you can see that this is all emails, current balance, or customer account number, credit card numbers, you have IBANs, which you can also have, obviously last names, dates, etc. So you can have a lot of different data types, and you can also have, for example, situations like where you can have, for example, names such as company written as CMPNI, and by reviewing the names of the companies, you can see that indeed these are all companies. And in this particular column right here, called Alpha 1, this is the multi-label that I mentioned. You can have two different labels based on the data that is in the column. So if you look closely, you have KF Aerospaces, but you also have Acetylene Sec Arnaud, you have some names, Josimel Langlais, etc. And you will have Air Canada, Apotex, etc. So you can see that in your sample, and you have also this Cargill Ltd. You can see in your sample you have both personal names and organizations, and this is designed, for example, if you're doing a lot of B2C and a lot of B2B, in order to, and you call them have them in one particular column, which is called customer, you can easily know that you have both of these data types in your column. And obviously, it works also in this particular case in French. And what I want to briefly just address here is this particular province. So you can see here that it's classified by regex. And this is something that I mentioned already, which is the ability to define your own particular regular expression. So in this particular case, we decided to create a regular expression for Canadian provinces. We have opted out to write a regular expression in this particular way. However, you can also create a regular expression based on the column name. So you can do that as well. And you can add new ones to this particular system. You can give it a name, you can write some kind of an expression and some kind of a data domain. So for example, if you wanted to add something called policy, and you wanted it to trigger on policy hashtag, you can do that, right? So you can do all kinds of different things, and you can say this is called policy, and then you can just kind of save it, and it becomes part of your expressions dictionary. So you can create expression dictionaries for all kinds of different things. If you need to have them classified and you want to add them to your version of the model, this is the way you can do this. And obviously you can override the classification results, so you can automatically pre-fill the column, so prof, and then you can select a specific different label that you want to apply. Which might be, I don't know, for example, this one. You just click on it, you save it, and it will override this particular column. And for each additional scan, it will remember this particular column. All right, and so last thing I want to show you is the data inventory. So the dashboard I talked about, this is how it looks like. So here you have the timeline. You can see when we scanned. So I scanned it, I think yesterday. We scanned one of the systems. You can see how many systems, how many different domains, how much personal data, and how much special category data. Below, you can see different locations of where the data is processed. And you can have simple cards where you can see how many different objects have been scanned, how many personal data objects have been discovered, and how many personal domains you have found. And in the data inventory, here you can filter based on whether you want to see just the personal data. So you can see here that we have reduced the number of columns, and then we can filter a specific, let's do this one. For example, if you wanted to see Swift, you can see here that it's in this particular column called Positia, or you can filter based on person, sexuality, nationality, geolocation, IBANs. You can filter on systems, so you can just see the data for one particular system, multiple systems. You can use the connection types. You can filter based on a specific connection type, on specific data locations as well, on specific technical measures, organizational measures, and even if you are so inclined on the database data types, etc. And you can obviously review all of the specific systems at any given moment. And what this allows you to do is kind of have at a glance the ability to see different categories of data, where they are contained, where you can find them in this particular intact one system, and what part of the model has classified them. So in this particular case, this is our ML engine. And here you can have obviously define and view all of your different systems where you can assign risks, etc. So depending on whether you're working with third parties, maybe you want to assign specific risks to specific systems, which may or may not apply to different kinds of systems. So you can do this here, and obviously you can your DPO or a responsible person can do that here. All right, that's it from me. I will open the floor for the Q&A. Thank you for your attention, and Petra, I'll give it back to you.
Thank you, Ana-Marija. Thank you for this amazing presentation and demo. And I will start the Q&A with the first question we had, and that is, do you send the data to the third parties?
So we don't send the data to any third party. All of our processing is done within your infrastructure. So there is no data leaving the infrastructure that the data discovery is installed upon.
Thank you, Ana-Marija. The next question we have is this module regularly updated, and how?
So yeah, our team regularly updates the module, and we have extensive release notes. We take the feedback from our customers. We evaluate the data discovery process together with our clients, with responsible people from the business, and then based on this particular information, we update the model. We continuously follow the new developments, both in the model optimization, but also obviously in the development of new models. We retrain the model, we include new categories. So recently we have added several different categories, such as IBANs and credit card numbers. Now we are doing some of the health insurance inclusion, pharmaceutical inclusions, etc. So we regularly update all of our models with new data and new approaches.
Thank you, Ana-Marija. The next one we have, how can I add my own entities?
So yeah, I'll just share briefly. So I've just showed that, but let's recap. So if you want to add your own entity, you go here, you add new. Let's call it I don't know. Let's call it index, and let's say that it's in a column called index, and we call it index. And this is how you just save it. And you can add it, and you can add as many as you like. So it's not a limited functionality. We obviously recommend to be very careful using the column names, because they might mean different things across different systems. But if your knowledge of the system is sufficient to create it based on a column name, you can do so. And if you want to use something like a regular expression, like we did here, you can create that as well. And in this case, it matches not the column name, but the actual data contained inside of the column. And obviously, if you want to update it, add new things to it, or maybe you want to alter it, you can always update it and keep it in this kind of way. So it's not static. You can always do something with it. And obviously, eventually, you can also opt out to remove them or just enhance them. But you do need to be like very conscious of the effect that they have, and be sure that you have applied the correct label.
The next question, I'm sorry, the next question we have is, can we create report with findings?
Yes, so yeah, that's a very, very good question. I actually thank you, whoever asked this particular question, because I actually forgot to show this. So you can load the results, right, for every particular scan, and you can export them based on, so you can export them and review them and see all of the data domains, all of the connections, all of the labels, all of the identified things. And here, obviously, if you want to quickly review them, you can also filter and review all kinds of different data. So yeah, this is possible. You can also create and see the reports on the data inventory as well.
Okay, and now we have a bit longer question. How does the unstructured data discovery work? Do I have to scan all of the documents every time?
Also a very good question, actually. The audience today is really asking good questions. I should have mentioned this. When we talk about unstructured data, as I mentioned with the ChatGPT model, you do need a lot of infrastructure to run them, right? What we opted out to do when we designed the unstructured data discovery, because of the amount of data that you have on your drives, etc., and obviously it's not the same scanning a small table and scanning a large contract, which might have 500 pages, right? In the initial scan, we will scan all of the location, right? So we will take all of the documents that are present in this particular location and we will scan them. This usually has as a consequence that this scan might be a little longer for large systems, but every subsequent scan, we will only scan those documents which have been changed, altered, right? So if you have written something in the document, if you have edited it in any kind of way, if you barely accessed it, right, we will scan it. And the reason for this is because it inherently builds efficiency, but also acts as a control for some documents which you will see during your data discovery process that you are not accessing and not using, and they contain personal data. It might be wise to remove them, right? So this kind of helps you to control this particular part of the process as well. It allows you to see whether the documents are being used and accessed. Obviously, you cannot automatically just decide to delete them, but you can actually review them because you will see that they have not been scanned at all. So this is how it works. Yeah.
Thank you, Ana-Marija. And now I think this will be the last question, and the questions we did not manage to answer, we will send you in our follow-up after the webinar. And this is, does data discovery support multi-labels?
Yes. I already tried to mention this a couple of times, but we will go into more detail about this particular topic. We enable multi-labels, and this is by design, right? You have to be able to classify multiple types of data. This is particularly relevant. For example, during COVID, we had a lot of companies go abruptly digital. So a lot of the contacts and bills, etc., started coming, via email. So perhaps the contact column has changed. You have a lot of the legacy things that have been updated through time. So you need to be able to cover both of these labels. And this is why our sampling, right? We don't rely on just the values that are the newest or the oldest. We really try to randomly sample in order to be able to capture both of these labels, to capture the changes through time, which are normal and expected. And if we need to output it, we output both of the labels, or, and this is something that I haven't mentioned, so thank you for question, it doesn't necessarily have to be two. There are, and we have seen this at the customer side a lot, there are columns in which we have, especially columns where people write in freehand, which might have 4 or more different labels. So sometimes we really have columns which have both address, phone number, email, and the name of a person written in one particular field in a column. So this happens. It's not very frequent. Usually it's dual labels, but it does happen on the client side that this is something that we see.
Thank you, Ana-Marija, for sharing all of your knowledge today, to showing us the demo. And thank you everyone for joining us today. We hope to see you again on our next webinar, where we will cover new topics related to privacy. And if you have any additional questions, Ana-Marija, please pull up the last slide so they can see our emails. Feel free to send me or Ana-Marija an email to discuss more about the Data Privacy Manager itself and the data discovery as well.
Yeah, I would be happy. I recommend, if you are interested in this topic, to read our ebook on data discovery. And I want to personally also thank all of you who have attended. Great questions. Thank you for listening. And I hope I will see you on some other webinar. I'm looking forward to it. And if you want to discuss anything related to even ChatGPT-3, if you must, you can contact me on my email. I'm happy to relate that to privacy protection.
Thank you, everyone, and looking forward to seeing you again. Bye.
Bye.